In this presentation, we're going to look at some worked examples of the Maclaurin series, and so it's two past exam questions. The first one is derive the Maclaurin series for f of x equals cos x up to and including the term x to the power of 6. Hence, and using the identity, this is a trigonometric identity, sin x equals 1/2 of 1 minus cos 2x. Show that the first three non-zero terms of the series are as x squared, for sin x squared, is x squared minus x to the 4 over 3 plus 2 to the power of, x to the power of 4 over 3 plus 2x over to the power of 6 over 45. Let's scratch that there. Now, use these terms to find an approximation for sine, the sine of 1/2 squared as a fraction. Alright, so, for what we have to do first off, this is just a bit of tongue twisting there. So it said to derive the Maclaurin series for f of x equals cos x. Okay, so up to okay, so this is here is the formula for Maclaurin series. Okay, there we go. So, what we have to do is evaluate it at f of 0. Essentially, what we're going to do is repeatedly differentiate the term, so we get and evaluate it each time at 0. So we get the term evaluated at 0, differentiate it, evaluate it at 0, and so on. Differentiate it again, get the second derivative, third derivative, and so on. And we also will apply this part here. So x over 1 factorial, and the third term there, x squared over 2 factorial, and so on. Just as a remark, actually, I'll move on from that. So, okay, what we're going to do actually is evaluate repeatedly evaluate the function and differentiate the function or evaluate it at 0. So starting off, we have f of x equals cos x. Okay. Now evaluate that at 0. You get 1. You're going to check that with your calculators. Okay. But this is the next part, the most important part. What is the derivative of cos x? It is minus sin x. Okay. So the next part, we find that the expression is, the derivative is minus sin x, and what we will do is get the evaluation of that at 0. Sine of 0 is 0, minus sine of 0 is also 0. Okay? So what we're going to do now is differentiate minus sine x. Now the derivative of sine x is cos x, so the derivative of minus sine x is minus cos x. Okay? And just as we evaluated cos of 0 equals 1, down here we would find that when we evaluate the second derivative of the function at 0, minus cos 0, we find that the answer is minus 1. So just to sort of emphasize, we're starting a bit of a pattern here. 0, 1, 0, minus 1. Okay. And just down here at the bottom, if you do integrate it again, if you mind to integrate minus cos x, you will get sin x. Again, the derivative of cos x is minus sin x, so if you get the negative of cos x, the derivative of that is sin x. Okay, so and evaluating sin x at the sin 0, we would get the answer to be 0. So the third derivative of the function evaluated at 0 is sine of 0 equals 0. Okay, so now what we have to do is keep going at that for a while. Gets a bit long and tedious, but essentially what I'm going to just to sort of emphasize is that we're just evaluating cos and sine, or minus cos and minus sine at 0. And essentially what was happening is that we're getting a sort of pattern like this. And so on. So 1, 0, minus 1, 0, 1, 0, minus 1, 0, and so on. So that's that part done. So let's just put it all together. This is the Maclaurin series again. Okay. Now we've got all this bit, so it wasn't that really too much to it. And all these terms here. So we have f of 0, the derivative of fx at 0, the second derivative of fx at 0, and so on. All we have to do now is just sort of add in these terms here. Okay. X over 1 factorial, x squared over 2 factorial, and so on. Now, the important bit is, remember our pattern. So f of 0 was 1. The first derivative of f of x evaluated at 0, that's 0. So this whole term goes to 0. The next term was f of the second derivative of fx evaluated at 0. That was minus 1. Okay. This is 0 again. And this is 1. And so on. We have 0. And we will have minus 1 x to the 6 over 6 factorial. Okay. So the question asks us derive the Maclaurin series up to including the term containing x to the power of 6. So we have 1 minus x squared over 2 factorial plus x to the power of 4 over 4 factorial minus x to the power of 6 over 6 factorial. But that's all we have to do there. The next term probably would be x to the 8 over 8 factorial, but we're not asked for that. Okay. So that one's done. Hence, on using the identity sine squared equals half of 1 minus cos 2x, show that the first three non-zero terms of the Maclaurin series are as follows. So let's just see here. Sine squared of x, or sine x squared even, equals half of 1 minus cos 2x. Let's just go back here a second. What is cos of x? This is equal to 1 minus x squared over 2 factorial, and so on. So cos of 2x, let's go back, sorry, is as follows. Cos of 2x equals 1 minus 2x squared over 2 factorial plus 2x to the power of 4 over 4 factorial, and so on, minus 2x to the power of 6 over 6 factorial. So what we have here is half of 1 minus let's just put in our expression again. So we're going to put in this expression here. 1 minus x, or 2x squared over 2 factorial plus 2x to the power of 4 over 4 factorial minus 2x to the power of 6 over 6 factorial, and so on. Well, you can see pretty clearly that we have 1 minus this term here. So that cancels out. They cancel out. I'm going to just get rid of them. Just also see that we have a minus here. So if we put that through, it's just going to change the signs the whole way through. Okay. So if we change the signs the whole way through, let's do that. Now, this is half of 2x squared, that's 4x, squared over 2 factorial minus 2x to the power of 4, that's 16, x to the power of 4 over 4 factorial plus 2x to the power of 6, that's 64 x to the power of 6 over 6 factorial, and so on, the other trivial terms there. Let's use this half here, this half term. Let's just actually cancel that through. So that's 2, 8, and 32. Move down a bit. There, I'll actually just go here. So what we have here is 2x squared over 2 factorial minus 8x to the power of 4. 4 factorial is 24, and 32 x to the power of 6 is 6 factorial is 720. Okay, and the other terms there as well. So you can see pretty clearly now the 2 and the 2 factorial. 2 factorial is actually just 2, so I'll actually just get rid of that there. 2 factorial is just 2, so the 2 and 2 cancels out. 8 and 24, that just leaves us with 3. You can divide both of these by 16 and you would get 2 and 45 there. So the answer is x squared minus x to the power of 4 over 3 plus 2x to the power of 6 over 45. Okay. Now, use these terms to find the approximation for sine squared equals a half. So let's just use our term there, x squared minus x to the power of 4 over 3 plus 2x over 6 to the power of 45. Just writing that down, bringing that down. So we would get, that's that's sine squared. That's sine x squared. So sine and a half squared equals x to the power of x squared, so it's a half squared, minus 1/2 power of 4 over 3 plus 2 power of half power of 6 over 45. Let's not use the other terms, they're just getting too small now. And let's just work this out. So we have 1 over 4 plus, minus half, that's half to the power of 4, that's 1 over 16 divided by 3, plus 1 over, actually just work this out, 1 over 440. So we would get 1 over 4 minus 1 over 48 plus 1 over 1440. Let's just simplify that expression there. That is equal to 360 over 1440 minus 30 over 1440 plus 1 over 1440, and we can leave that as 331 over 1440. Okay, I have another presentation there, but this one's gone on long enough, so I'll just finish it there.